Morning, ladies and gentlemen. Let's talk about power. First things first, direction matters. The direction that we move. Work equals force times cosine theta times delta D. What do these things mean? Thank you, sir. Okay, so in this one we have the force is up and my displacement is up, so...
Holy smokes!
Okay, so that's that one. Now what's the difference when I go...
You're doing work both times.
I'm doing work both times. One I'm going up, one I'm going down. How does that affect my work? Tell me about the sign. Positive, negative, nothing? Well, when I'm going up, my work is going to be positive.
Positive.
Cosine of 1. When I'm going down, my work is going to be negative. Cosine of 180 is negative 1.
Yeah.
And then what about when I'm
Just horizontal.
horizontal?
You ain't doing no work. You're
I
just
ain't doing
walking.
nothing. I'm just chilling. I'm just walking. Okay, so nothing there. Could we calculate the work as I go up?
Well, you'd need to know how much you weighed first. The
Okay.
work you're doing against gravity.
And then what else do we need to know?
Well, the displacement.
Okay, if we measure this, that's 0.91 meters.
0.91 meters.
And what if I told you my weight was 680 newtons?
680 newtons? What the heck does that mean?
Can you figure out how much this more weighs in LBSs? So how can we figure out what the work is here? Well, we know that work equals force times the cosine theta times delta D. And we know that my force is 680 newtons. The cosine of 0 is just 1, right?
Yeah.
So times 1. And then times my displacement was 0.91 meters. Do I even need to put the 1 in there?
No.
No, don't put it in there. 680 times 0.91, and I get 618.8. What are my units again?
Newton meters, which is also a
Newton meter, which gives us a
joule.
joule. Beautiful. Okay. What else? What's next, Miss Moore? Power is the rate at which work is done.
Oh, it's how much work divided by how much time.
So could we calculate our power here?
Well, I don't know.
We got a timer?
Ta-da.
You got me?
All right.
I'm gonna go fast. Should we do them both? We can do both.
All right. So let me.
Okay.
You say on your mark, set, go, and then stop when you're up there. Don't hit
Okay.
your head.
Do you want me to tell you one or do you got it?
No, you tell me when to start, and I'll start it.
Okay, ready, set, go.
Okay, that was 2.17 seconds. Trial 1 is 2.17 seconds.
2 point what, sorry?
17 seconds.
17 seconds, okay. So that's time 1.
Yeah.
Let's do one other time. This time,
Say when to start.
ready, set, go.
What? Wait a minute. You climbing like an old man. Come on. Don't hurt yourself. Don't hurt yourself. And boom. 19.68 seconds.
Dying. Okay. 19.68.
Yeah. So,
Pause the video. Calculate it. I'm gonna change colors. Do it. Okay, so for what is this? Okay, power with
So
time 1.
you climbed the same height. It was the same U, so it was the same work each time.
Same work, and our work is right here. Power equals 600, I'm gonna call it 619 joules divided by my time for the first one was this. Okay, I'm just gonna set up my second one over here. Same work, same me, same work. This time, 19.68 seconds. And we've got 619 divided by 2.17, and I get 285.
That's joules over seconds.
Okay, and then for my other one, 619 divided by 19.68, and I get 31.5. 31.
5 joules per second.
Okay, so which one had more power?
Well, the one where you went up fast, girl.
Yeah, I needed more power to go faster. Okay, the rate at which work is done. More faster, more power. Units of power, as we just saw, watt, watt is joules over seconds. We saw that over there.
So it's 285 watts and 31.5 watts.
Mm-hmm. And, oh! Okay, so watts is the same thing as joules per second. A joule is a newton meter. Second is still a second. A newton is a kilometer times meters over second squared because of mass and
That'd
acceleration.
be a kilogram meter per second
Oh,
squared.
Sorry, what did I say?
Kilometer.
Kilogram.
These things happen.
I'm thinking about the meters over here. And that one carries through, and bam!
It's all the same.
Yeah, it's all the same. And it simplifies down to a watt.
Yeah.
Watt? Okay. Same thing as saying, what we just saw is those are the units, these are the symbols. Power, watts over time, work over time, and then work is force times distance, time.
Distance over time, that looks familiar to me.
D over T, velocity equals D over T.
Oh, yeah.
That's where we get this from. Okay, everything's squared
Put
away
a box around that in your notes.
there. Yeah, box this part right here, right?
No, the whole thing.
Oh,
The whole thing. Put the whole thing.
Okay.
Speaking of box.
Practice problem. A box that weighs 575 newtons is lifted 20 meters straight up by a rope attached to a motor in 10 seconds. How much power did the motor develop? Pause the video. Do it.
Do that information mining. Choose the equation. Plug in the numbers.
Okay, all right. So, force is
575 newtons.
5 newtons. Displacement 20.0 meters. Straight up by a motor. Straight up, that means okay. Time is seconds. How much power? So power is work over time. Work is force times distance, right?
Yep.
And we're going straight up, so that means it's going to be times 1, right? The cosine of theta?
Yep. The force and the displacement are in the same direction.
Okay, so we can just use the cheat sheet one. The force was 575 newtons times 20 meters divided by 10.0 seconds. And newton meters per second, so 575 times 20 divided by 10, and I get 1,150. What are units?
Watts.
Watts.
What?
Watt is our unit. Watt, okay. Too easy. Okay. Bob again. Bob, his weight is 925 newtons, climbs a 0.912 meter up on a table 2 times. The first time in 2 seconds and the second time in 17 seconds. What was the same both times? What was different? Didn't we do this?
I can think of several things that are the same.
What are the
The
same?
weight and the height.
Okay, the
What's
weight.
that other thing that's the same though?
The weight and the height. Well, work is force times displacement, and our force we get from our weight, right?
Yeah.
So basically our work should be the same, yeah?
Work should be the same. Work is the same both times.
But what's different? Well, power is work divided by time. If the time is changing, that means our power is going to be different.
Which one was more powerful, 2 seconds or 17 seconds?
Think about when Miss Moore climbed up on the table. Which time was she more powerful?
Yeah.
Okay. Should we answer this question for them, or do they got it?
Nah.
Okay, moving along. Oh, another practice problem. A 1.1 kilogram car starting from rest accelerates for that many seconds. The magnitude of the acceleration is this. Determine the average power generated by the net force that accelerates the car.
Seems like there should be more to this.
Let's write down what we have.
That's 1,100 kilograms.
Okay, so mass is 1.10 times 10 to the third.
That's 1,100 kilograms.
1, 2, 3, yeah. What else? Oh, it's starting from rest.
It's a good observation.
Accelerates for 5 seconds. We're done. No, just kidding. The magnitude of the acceleration is 4.60 meters per second squared.
Okay, boys and girls, pause this video. See if you can do this on your own. Go ahead. That's a good place to start, Miss Mo.
Let me start with the basics, right?
How can we get the force?
So I have my time, right? 5 seconds. We need the force. So force equals
That's Newton's second law.
mass times acceleration. Whatever. So 1100 kilograms times 4.60 meters per second squared. 1100 times 4.6. 50, 60.
So now we've got the force. I don't see displacement anywhere. I don't see distance mentioned.
How are we gonna do this? Okay, well we have our velocity, time, acceleration.
Oh, we can get displacement from the kinematic equation.
We need displacement.
What variable is missing?
We don't have this one. That's gonna be right here. T equals
Watt.
watts. This goes away, right?
Yeah.
Okay, so 1/2 times 4.6 meters per second squared times 5 seconds squared. Let's see what we get here. 0.5 times 4.6 times 5 squared. I get 57.5
Meters.
meters. And we put that right here. That's a 7, guys. Okay, I'm not done yet. I gotta put this in my calculator. So 60 times 57.5 gets me that, and then divide it by 5. I get 58190. And what we're talking about here, newtons. What am I? Newton meters seconds. That is a
Watt. Sweet.
That's it. We're done.